Greetings, Mr. Sutton here, bringing you the Pre-Cal Honors 7-1 Part 2 homework solutions on graphing conic sections. On this problem, I've got something squared plus something else squared equals 1 with denominators that are different. So that's an ellipse. I have a center of -2, 6. And already I can see that's going to be off my graph, so I'm going to have to make my grid lines go by 2's. Now let's just get our 2 radii here. The x radius, that's the square root of 25 in this case, because that's under the x squared. So that's going to be 5 left and right that we're going. And for the y radius, the ry, that's going to be square root of an invisible 1 down here, which is also 1. So again, my grid lines, I need to make those go by 2's. I'm going left 2 and up 6 for my center. And then the x radius, I'm going 5 to the left, 5 to the right. For the up-down radius, I'm going 1 up and 1 down. So this is going to give me a very narrow ellipse with this scale, but that's what I need to draw. For this problem, I notice I've got something squared minus something squared. That's the format of hyperbola. So I need my center, which is going to be 0, 0. And now for the radii, I've got a left-right radius of square root of 1, which is just 1. Up-down radius, ry, that's going to be square root of 16, which is 4. So I'm going center of 0, and a scale of 1 is going to be enough to fit all of this. So I'm going left 1, right 1, and then up 4 for the ry and down 4. Draw the box. Draw asymptotes through the corners of the box. And next, I've got a positive x squared. That tells me that I'm going to have a left-right hyperbola. So I've got a branch over here on the left, and then another branch over here on the right. On this problem, I've got something squared minus something squared, so that's a hyperbola. For the center, be careful here. The y is given first. So we've actually got 3, 1 for the center, not 1, 3. And now for the rx, that's going to be the square root of the 4 down here, which is 2. For ry, the y radius, I'm square rooting the stuff under the y, so square root of 9 gives me 3. And if I'm over 3, 1 and going left, right by 2, I can fit the right by 2 here, except I'm not going to have any room for my actual hyperbola branch if it's a left-right hyperbola. So just to be on the safe side, I'm going to make my scale go by 2's on this one. So now my center of 3, 1 is going to be right here. And I'm going left 2 and right 2. And then we're going up 3 and down 3. Draw the box. Asymptotes one way, asymptotes the other way. Since I have a positive y squared, that means that I have an up-down hyperbola for this one. So I've got a branch up top, there we are, and another branch down below. For this problem, I've got the sum of 2 squares, and we've got these different radii underneath, these different fractions here. So this is an ellipse. So let me start by getting my center. I've got -1, -4 for the center. And then for the x radius, that's going to be the square root of 9, which is 3. For the up-down radius, the y radius, that's under the y squared here. That's the square root of 1, which is also 1. So if I'm going, let's see, -1 down 4, and then I'm going these different directions, I think I'll just barely be able to fit this on my graph using a scale of 1. So we'll stay with a scale of 1. So here's our center of -1, -4. And then I'm going left 3 and right 3 because that's my x radius here. And then I'm going up and down by 1 and connecting the dots. For this problem, it looks like I've got an ellipse. I've got an x squared plus a y squared, and they've got different things underneath here. So let me start by getting my center of -2, 0. And I've got an x radius of square root of 9, which is 3, an up-down y radius of square root of 25, which is just 5. If I go -2, 0, and I go 3 left, right, and 5 up, down. I can still fit this on a graph with a scale of 1, so I'll just keep my original scale. So there's our center of -2, 0, left 3, right 3 for the x radius, and then up 5 and down 5 for the y radius, and connect the dots. On this problem, I've got an x squared plus a y squared, and they don't have the same denominator. It equals 1. So this is an ellipse. So I have a center of 0, 1, x radius of square root of 9, which is 3. For the y radius, I square root the 4 that's under the y squared here, giving me 2. And if I'm going 0, -1 for the center, going left, right, 3, and up, down 2, I don't need a scale of anything other than 1 for that. So let me graph this now. 0, 1. We're going, again, left 3 and right 3, and up 2 and down 2 for the y radius, and now we draw the ellipse. On this problem, I have something squared minus something squared, so that's definitely hyperbola. My center on this one is going to be 0, 0. For the x radius, we've got square root of this 9 here, which is 3. For the y radius, if it makes a difference, we have the square root of this other 9 over here, giving us 3 again. Let me use that to make my helpful box. So we've got my center 0, 0, and we're going left 3 and right 3, and then we're going up 3 and also down 3. So it's actually not just a rectangle, it's a square that I'm making here, but it's not always a square. This one is, though. So now I draw my asymptotes through the corners of this square. There we go. And since we have a positive x fraction, that means that this is going to be a left-right kind of hyperbola. So I'm doing a branch over here on the left side, like so, and a branch on the right side, like so. Again, going through that point and getting close to the asymptotes without touching them. On this problem, I have something squared minus something squared, so this is hyperbola. For my center, I'm going to have -1, 2. And then for the x radius, I've got the square root of 9, which is 3. For the y radius, there's an invisible 1 underneath the y squared, so I'm doing the square root of 1, which is also 1. And now before I graph anything, let me check my scale here. If I'm over at -1, 2, and I'm going, let's see, left and right by 3, and up and down by 1, I'll be able to fit everything, so let me keep my scale of 1 here. So -1, 2, that's our center. We're going left 3, right 3, up 1, down 1, drawing the box. Now I draw my asymptotes through the corners of that box. And there's the other one. And now I draw my branches. Now looking at the original here, it looks like the x fraction is positive. The x squared is positive. That means that this is a left-right hyperbola. So I've got a branch over here in this little itty-bitty spot, but we'll fit it. And then I've got another one over here on the right side, and there's my hyperbola.